Hello, this is the next video in the RTC Bricks video demonstration series. Here the project is on GitHub and all the details there, but also once you install it or access my project page, you can see this table of content, and in this video I'm going to go over some of the audio and video effects. So that those are mostly covered in the media topic here, and they can mostly be done using the video IO component and maybe a few other components such as video mix that I'll describe. End-to-end insertable streams, pretty old technologies now, but allows you to do end-to-end encryption of the media, and it's very simple to use here using just one property. Video mix is what I'm going to focus today here. Video mix is a new component which allows you to take more than one video IO elements, some other media stream kind of elements, and be able to compose the video, each frame of the video, using those by using canvas operations. The details are here. One example here is to add a date. So if you run this, typically we'll see the date attached in the video itself, which can then be published. This one is screen share with webcam video combined, so that you publish your webcam with both. This one is allows you to use video mix to change the basic image properties using image processing. So you can, for example, increase the brightness, reduce the contrast, make it grayscale, and so on, even blur. This one just takes multiple video elements and combines them, composite image, such as in this case it just takes one video and makes a 3:2 display. So this is one video which can then be published by your application. The sample code is just shown here, how to do different layout. Now here comes the more important part. So there is image processing using third-party tools you can do. This one shows how to do it using the MediaPipe and TensorFlow applications that was released by Google several years ago. This is the source video, the background detection, doing blur, removing background, and using virtual background. This one is the same thing, but with a less accurate model, a BodyPix model, which was before MediaPipe. This one is just tracking the mouse and eye so that you can use that information for, say, auto framing and so on. This one is composing multiple webcams into a single one, so that if you have multiple webcams, you can put it in an angle, and then the video which is sent out gives two different views. And this is interesting because I have a virtual camera here, and it kind of uses a blur in the center where the two images are joined. This one is temporal manipulation, so I can speak and it saves those frames and shows how to do slow motion and fast forward. So right now it's doing slow motion, and then after some time it will do fast forward. So these kind of things can be used as video effects as part of the video conferencing product or something else independently. This is an interesting one. So this one shows slow capture to take a snapshot. I have a separate project for this, capture slowly, which was done before, and this is just encapsulating that and showing it how you can apply it with video IO component. These are just simple applications. This is a sketch art which uses background blur, background removal, and some other image manipulation to create a sketch art. This one is using a p5.js library, external library, to implement one of these special effects. So for example, you can have snowflakes popping up on your webcam video, you can have pixelation of your video, particles exploding, rain effect, bouncy balls, explosion, fire. All these are demonstrated as part of using an external computer graphics library, in this case p5.js. Then also have opencv.js, which allows you to do many things, and one of the things is detect a rectangle in the video or image. And here what I do is I put this image and the webcam video, and then it superimposes the webcam video in this frame of the image, and then that image, the whole body, is then that's sent out as a webcam video. So here my webcam video is basically showing up on that frame TV. How it is done is shown here. Another integration with different graphics library. So in this case, the same effect, but here it allows you to select where the frame will be put. So I can just say that, oh, put the frame not there, but put it here, and it will put it there. This one uses the glfx library, very good graphics library for other effects. So there are a bunch of effects which are part of this. So things like zoom, blur, swirl, hexagonal pixelate, and a lot of others. Some examples are shown here. This is an interesting one which allows us to find difference between two frames, and based on the difference, how much difference was there, it can start recording or not. So in this case, I use the pixel match library to create a security camera kind of use case, but the benefit here is that it doesn't record everything. It records only when there is a significant difference or different motion or change in the webcam feed. Then it starts recording like few seconds before the change happened to when the change is stopped few seconds after that. But an interesting use case. And finally, this one is about character recognition using third-party select library. So the use case here is if you are doing, say, screen sharing, and suddenly if you want to capture notes on the screen sharing, you can just click a button, it will capture the screen, detect the characters, words, and then take that in the notes for your note generation and so on, directly from the screen share video that you're receiving, rather than from the text chat or from voice input and so on. Actually, I should show the demo of this. So let's say I do this, I do capture. This will prompt me for screen share. Say I select the same tab, maybe, or different tab, and instead of window, and go back to that. Now that window, that tab, the other tab is getting shared. Now what I do is I select a part of it, maybe this one, and try to capture, detect what is written there. Now this is doing, this is received video, and part of it got detected correctly. Okay, for audio signal processing, there are a bunch of things which are already available in the web audio API using the audio context. So I wrap it in a web component called audio context, which allows you to do many, if not all the APIs which are available in the audio context, but in a more web component-y way, as you can see in these examples. One of the example here is the waveform detection generation based on the audio. So when I speak, it detects that and generates the waveform using the audio analyzer node and audio context and so on. There is a speech to text component as well, and that uses the built-in speech recognition and speech synthesis API of the browser. Chrome has very good support for many languages. So for example, here I'm just speaking and detecting it in real time. And
so, for example, here I'm just speaking and detecting it in real time.
Play transcript will also convert it into speech and play it that you can hear. Language support. So for example, if I say Hindi, kya haal hai, it does detect that. The next one is using that speech text to do auto captioning. So in this case, whatever I speak should get auto captioned. Open and close caption both are implemented, and you can also do this from typing instead of using speech text. But this shows how the two components, video mix and speech text, are used together in some use cases here. So this one is the speech bubble container component, which allows you to do, text chat or speech to text detected text displayed in a comic book kind of display in a user interface. When I do this, these are pre-populated right now. I have also doing real-time speech recognitions attached to this user, so that got displayed, or whichever user is currently active. And once this is active, you can also type the text and that will appear as the speech bubble. There is another component which is similar to this one, but displays it in more comic book style user interface for the webcam video. So in this case, the webcam video is basically captured, images are captured, and then they are converted into more like a comic book character like this. There are some differences between these two available there. This is another effect which is for 3D display in a video conferencing layout. I use three.js to display different elements. These can be video boxes in a video conferencing layout. You can move these things. You can move the perspectives. You can move the camera around using the standard three.js input controls. And there is a different version of it which is more efficient because it uses the CSS 3D perspective rather than a three.js library which converts everything to canvas first. So this one uses just CSS 3D perspective. Similar concept. You can use your manipulation input to change the camera positions and so on, and display the user interface like that. This just compares the two. Then there are a couple of web components which allow you to do spatial audio. I already talked about audio context which can be used, but here there is a spatial audio which can be attached to a flexbox which allows you to hear from one or another place. And there is another one which is audio space, which attaches to virtual space, the 3D layout that I described. And in addition to the sound coming from left, right. It also does distance, so sound will fade out if it is very far and so on, as in a 3D layout. So those are the audio video effects and 3D projections that I wanted to cover in this particular video demo. There are a lot of other features that will be part of other video demos. Thank you.